Today we are going to get see the basically two devices. One we are going to get say this is the transformer. Another here we can say this is the three-phase induction motor is there. Now we are going to get compare why this transformer induction motor is going to get say same. So when you are going to get say transformer, so it is a static device, no moving part is there. So if you are here you are going to get loop. So this is the one portion which is called as the rotor of the motor, and it is a moving. So it will continuously move. So we can say it is a rotating devices. Now when you are going into the transformer, there is a one winding which is known as the primary winding, another winding is known as a secondary winding. But here primary winding remains stationary, secondary winding is going to get remain stationary. But on another side, if you are going to into induction motor, then this is the stator. You can say this is the wire from which we are giving the supply. The supply is going towards the machine and it will go to the winding. So this winding is called as stator winding. And another side on this rotor, are the slots. So on this slot, we can say this is the rotor conductors. These are the rotor conductor. In between these two, there is very small gap is there. So whole rotor is uniformly wound over this. So this is the rotor conductor. So it will become secondary. This will become primary. Now concept is clear. Inside the transformer, when we are applying the supply, this supply is alternating nature, alternating type of supply. Transformer never work on DC supply. Likewise, this is the induction motor. Induction what itself indicate you it is AC machine. So the similarity, main similarity is it is also AC machine, it is also AC. Concept clear? So when we are giving supply to the transformer, what is going to happen? Alternating voltage is whenever going to get applied across the transformer, and alternating current will flow through it, which will induces the alternating EMF, which will induces alternating into primary winding. Yes or no? So through the core, flux is going to get passed. That flux is also having the nature is alternating nature. And in secondary, there is the EMF is going to get induced. So this is a self-induced EMF. This is a mutually induced EMF. So, but it is a no moving part is there. So you can say static EMF is there. So here it's coming out, and if we are connected the load, then alternating current will coming out. That is the I2. And if load is connected, then alternating voltage V2 will are coming out. So if we are going towards this induction motor, the induction motor alternating supply given is alternating. Supply given is alternating. But because of it is a three phase, what is going to get happen? Here, three phase supply will give you three phases, means three phase balance supply. Means all the three phases is having equal magnitude and displaced from one another by an angle of 120 degree. Means at any moment, the maximum value of the EMF induced or maximum value of the flux produced is always 1.5 times the maximum value of that quantity. Means if flux is considered, then that flux is 1.5 times maximum. And how it will changes? At 60 degree it will go to get change. So at any instant you will go. You will finding out it is remains same. So on this side, if you are going to let's say this is your stator. Now here the main difference is between this winding, stator winding, and this is the rotor. There is a small air gap is there. This air gap must be small. So what is going to happen? You will check now the width of this rotor. So my rotor width is this much, and you can go and you can check this the width of the stator also. So inside the stator you can see this is the width. So I can say this much is the width of this. So you can see same is the width of the rotor. Even though you can say the winding is coming outside, but actually working area is this, where you can say there is a slot is provided, and inside the slot winding is put there. So concept is clear here. Is there anybody there any doubt regarding this? So when we are going with this, so another point is that now this body is fixed, but it is having circular shape. So that's why, because of three phase supply displaced from 120 degree and having the common magnitude that is 1.5 times maximum value, it will produces the flux which is a rotating in nature. So we have said RMF means rotating magnetic flux. Now how it will going to get achieved? It will going to get achieved by the three different phases. Three different phases. If you are taken, it is a one line at any moment, any instant, it is a constant. 1 point times the maximum value. But it is a moving. Physically, it is not possible to see. Physically, it is not possible to see this. But you can say this is a stationary winding, it is not moving. But the flux produced is moving from this winding to this winding, this winding to this winding, this winding to this winding. So it is moving. And that is given by Ns equal to 120 F by P. F is a frequency of supply, P is the number of poles. Now again here the question is coming out, sir, how the number of pole is going to get created? So here number of pole is going to get created. You can see these are the coils. So from which slot you are taken it? From which slot? This is the coil. From this slot you are taken, it is going and it will go into another slot. So if this is the one slot which is used for the, it will create N pole, then another winding is going into the S pole. So N pole, S pole combination it will create. So after that you can observe here, it is the rotor. Rotor weight you are going to get set, and rotor is going to get moved here. Rotor is going to get moved. So if you are going to get see the weightage of this rotor, so it may be around 1 or 2 kg. But in a transformer, there is a no moving part is available. So whatever when I have initially my supply will come. Initially my supply will come and just it will touch the winding. It will pass the winding. So this supply is called it as no load current. And 3 to 5% of no load current is required here. Because here no load is connected. Transformer, no part is going to get moved. But as compared to this motor, there is motor has to drive this full weight. So initial supply which is coming out, which is I0, no load current, that no load current is coming out 30 to 40% of the rated supply. So huge amount of current is there, and this is the reason why there is efficiency of the induction motor is less as compared to transformer. One is, this is the movement. So movement coming out means frictional windage losses will coming out. Frictional windage losses. Another already you are going to get see here everything. So all of you getting this point?
Yes.
So this winding is going to get moved with the speed that is called as Ns, that is the synchronous speed. This is the rotor which is going to get rotated. This speed is called as rotor speed or actual speed, or it is also called as motor speed. Rotor speed, actual speed or motor speed. If the speed of this winding and if speed of this rotor is going to become same, then it will become stationary. Even though it is under running condition, because both are going to get synchronized with one another. Both are going to get synchronized with one another. And if they will synchronize, then this concept is used in case of synchronous machine, synchronous motor, where there is a requirement is that this stator winding speed, that is the Ns, synchronous speed, and the rotor speed must be matched. This is the one case. Then second case, if this Ns, synchronous speed of the rotating winding, is more than the speed of this rotor, then this machine will work as a induction motor. And if this synchronous speed is less than the speed of this rotor, it is less than speed of this rotor, then same machine will convert it into induction. It is called induction generator. Concept clear? So three concepts were taken. One is synchronous motor. In synchronous motor also, if you are going to see that this portion remains as it is. Means from three-phase induction motor, we are going to take its stator winding as it is, but we are going to make changes with the rotor. There, third portion is going to get added is the excitation circuit. Means we will want to drive this rotor. Again, I will repeat. In synchronous motor also, what we are going to do? We are taking this portion as it is. Means from induction motor, we are taking stator winding, stator itself like same is coming out. Now, we will take the rotor there and we will make the arrangement in such a way that this rotor will move and achieve the speed equal to ns. And for that we are utilizing excitation circuit. So third circuit is coming out after stator, rotor and excitation circuit. In case of induction motor, there is no need of excitation circuit. Whatever supply given, supply is the 3-phase, balance, having equal magnitude and displaced from 120 degree. So itself it will produce in rotating magnitude. Now same case is happening with single phase induction motor. In case of single phase induction motor, you are giving the supply is having alternating nature. Because of the alternate nature, positive cycle and negative cycle is cancelling each other. So they will get the torque like this. If it is going forward direction, so up to maximum value it will come, then again it will become 0. Again it will go in another direction, again it will come. So it will going, no movement is going to get happen. So what is the requirement here? Here the requirement is that you have to break these two jigs. Either you will increase the forward torque or reverse torque. And for that purposes, whatever this winding is given, now here it is a 3-phase, there you can say single phase winding is there. This winding is divided into 2 parts. One is the main winding, another is auxiliary. And on the basis of this, we can say that there are different methods is going to get created. Different method means you can say starting of single phase induction motor, or you can say it is a type of induction motor. So here you can say main winding and auxiliary winding. So both is having 90 degree angle. Both is having 90 degree angle. So we can say we are splitting the phase because it is a single phase. Single phase means one phase is coming. So one phase is converted into 2 phases having 90 degree. Concept clear? Again, if in this phase we have put one capacitor, so we can say it is a capacitor start motor. If we are putting one capacitor main winding, one capacitor into auxiliary winding, then we are going to say capacitor start, capacitor run motor. And likewise, again there is a shaded pole and other options is there. But try to understand the basic difference. Always try to consider the motor on the basis of transformer first. For all AC machines. If you are knowing this transformer properly, if you are having the knowledge of this transformer, then and then this will become very easy. In working principle also, what we are going to get say? We are going to get say a voltage is going to get applied, wire is there, so current is going to get flow. Current will come in now, so current will flow into these windings. Current winding is having N1 number of turns, current is I1, so it will produce as magnetic field. Magnetic field means what? Rotating magnetic field, not alternating. It is rotating magnetic field with Ns equal to 120 F by P. So it will going to get created. Now what you are doing? You are putting this rotor as a stationary inside this winding. So what we are doing? This is the combination. So this rotor is going to get moved inside the winding. So rotor is going inside the winding means what? It is having uniform air gap. So whatever the flux is produced by this coil is come and it will come around this rotor. So complete rotor is having the flux. So what happens? This is the body of the rotor. So this body of rotor is going to get cut the flux. This body of rotor is going to get cut the flux because of its own. So as soon as it will cut, there are two sides, there are end rings is there. So these end rings are making it a closed circuit. Whenever it will cut, according to Faraday's law of electromagnetic inductions, an EMF is going to get induced. And it is in rotor, so we can say E2. And this is a closed path is provided, so current will coming out I2. So rotor current is coming out. Now this rotor current coming out, so there is a magnetic field is going to get created inside this body. Because of MMF2 is equal to N2. N2 means this is the bar. How many bars is there? Multiplied by current I2. Now magnetic field produced by this and magnetic field produced by this. Both magnetic field will interact with one another. And then it will produces the force. That force is turning and twisting force is nothing but torque, which will going to get drive the shaft. Means it will going to get drive the load. Here there is a picking water from the well is the function. So load is connected here. So our motor is from this portion to this portion. And this is your load connected. Okay? Thank you.